Good morning, class. Today's lesson is 4.6 to 4.7 notes on isosceles and equilateral triangles and on congruence transformations. Here's today's class. All right, Hannah, if you can start us off with the first answer. An isosceles triangle has two congruent sides called
legs.
Very good. And we can see in the diagram here, the two congruent sides, or the legs, are marked with hash marks to show their congruency. The angle with the legs is called the
vertex.
Yes, vertex angle. And do you see how up at angle A, that's the vertex angle. It's the angle that is touching both of the legs. The side opposite the vertex angle is called the
base.
Yes, very good. And you can see the base BC in our picture here. In an isosceles triangle, the two legs are
congruent.
Yes, and the two base angles are
congruent.
Very good. And you can see how we have the leg marked congruent. So I would say leg AB is congruent to leg AC. And you can see the two base angles marked congruent. Angle B is congruent to angle C. So Hannah, how many eyes do you have?
2.
Good. How many eyes does grape have?
2.
How many eyes does cookie dough have?
2.
Yes, just like we all have two eyes, an isosceles triangle has two congruent legs and two congruent base angles. You can also see all those points demonstrated in the picture on our notes. Now take a second to look in your book at the top of page 286. Here we go. Here is the top of page 286. And I went ahead and drew it as well on this whiteboard, so it could be a little bit bigger for us. Sorry about that. All right, first question says, name two unmarked congruent angles. Now, I know that we can literally see in the picture that angle G is congruent to angle J. However, it asked us to name two unmarked congruent angles. So I know if this leg is congruent to this leg, then I must have an isosceles triangle right here. So I'm going to mark this angle right here congruent to this angle right here, which means to name this angle, I might call it angle FGJ. So angle FGJ is congruent to angle FJG. And that's my first answer, 1A. Now, my second question, 1B, says name two unmarked congruent segments. Now, again, I know that we already know that segment FG is congruent to segment FJ. However, we're trying to name two unmarked segments. Let's kind of think a little outside the box here and take a look at these angles are already marked congruent. If those angles are congruent, that means I have an isosceles triangle right here, this large triangle GHJ. And since the base angles are congruent, the legs must also be congruent. Now, notice I didn't name the base as one of my congruents. I named my base angles with my legs. The legs kind of go right across from the angles. So you could even turn the picture if it's easier for you to see. Now the base angles look like they're at the bottom, and it kind of looks more like our original diagram. Let me turn this back here, and let's name our two unmarked congruent segments, and that would be segment GH is congruent to segment JH. All right, let's move on. We're going to need some help from our class. All right, back to our class here. Yes, Hannah?
Can I go to the bathroom?
Yes, go ahead. Just grab a pass.
Okay.
All right, let's continue with our notes. All right, next part of our notes. An equilateral triangle. Equilateral means all three sides are the same. An equilateral triangle is also blank. What word am I looking for here? Yes, cookie dough.
Equiangular?
Equiangular is right. Very good. So if all three sides are the same, all three angles are also the same. Each angle in an equilateral triangle measures how many degrees? Now think about this one. We know that a triangle has 180 degrees. If all three are the same, how many degrees does each angle have to have? Grape, yes.
60 degrees?
60 degrees is right. All right, let's take a look at our book at the middle of page 287. All right, I went ahead and drew the diagram from page 287. You can go ahead and draw this on your notes paper as well. Looks like we have another isosceles triangle here. I know because I have two base angles that are congruent. Now, if I travel right across from the base angle, that would mean that this side is also congruent to this side. Now, if you're having trouble seeing it and you need to turn your paper around, no problem. Now we have the base angle on the bottom and the two legs congruent, but I'm going to keep it at its regular orientation. I'm sorry if I'm making you dizzy here. All right, and let's answer our two questions. How big is the measure of angle M? Now, they all add to 180. M and P are the same. I don't see any variables in this picture, so I'm just going to put an X here and an X here, and I'm going to go ahead and write myself an equation because I know that my X plus my other X plus my 120 must equal a grand total of 180 degrees. And I'm going to go ahead and solve that. So that would be X plus X, which is 2X plus 120 equals 180. I'd like to get X alone. Let's subtract 120 from both sides. 2X equals 60. Again, I want to get X alone. Let's divide both sides by 2. X equals 30, which means this angle, 30 degrees, this angle, 30 degrees, 120 plus 30 is 180. So I know I did it right. The measure of angle M is, in fact, 30 degrees. What is the length of segment PN? See how there's no line written above here? This is actually asking me the length of PN. And it must be the same as this, so 11 centimeters. All right, moving right along. All right, we are now at the diagram at the very bottom of page 287 where it says guided practice. And again, I went ahead and drew the picture right here on our board. Now we have another isosceles triangle. I know that because I have two markings that show that the legs are congruent. So I'm going to go ahead and mark in that the angles are also congruent. All right, now my job here is to find both X and Y. I'm going to start by finding Y. Since we know the legs are congruent, it would make sense to simply set an equation of setting those two sides equal. So 4y minus 2 equals 2y plus 2. I'd like to get my y alone, but first let me get my y's together. So I will subtract 2y on both sides, which leaves me with 2y minus 2 equals 2. Let's get this y alone by adding 2. 2y equals 4. Again, let's finally get y alone by dividing by 2. Y equals 2. I like to check my work, so let's just do a little mental check here. If y is 2, this side would equal 6. And if y is 2, 8 minus 2 also is 6. So I know that the sides are congruent. I know that our work is correct and that y does equal 2. Now, a couple different things I could do for x. Let me just see if Tuk Tuk can erase this for me. Awesome. Thank you. All right. So now let's find x. Now, a couple different ways to do this. I know that these angles are the same. So I know that this equals 6x plus 8. So I could write an equation here. 6x plus 8 plus 6x plus 8 plus 80 equals 180. I'm going to kind of do it an alternate way, but very similar. If my whole triangle is 180 and I already used 80, I know I have 100 to go. These must be 50 and 50. So why don't I just take my 6x plus 8 and set it directly equal to 50, knowing that 50 plus 50, and these have to match, plus 80 equals 180. So doing that, I can solve for x by subtracting 8. 6x equals 42. Divide by 6 to get x alone. I know x is 7. That is the correct answer. Now let's also see it the longer way, which is an equally great way. I could have written out my 6x plus 8 plus my other 6x plus 8 plus my 80 all must equal 180. Let's combine like terms here. Let's say that 12x plus 96 equals 180. Subtract 96 from both sides. 12x equals 84. Divide by 12. And again, x equals 7. Two alternate ways to do the same thing, but let's go ahead and put our x equals 7. If I want to check my work, I could plug it in for x. 6 times 7 is 42. 42 plus 8 is 50. That's 50. That's 50. That's 80. Adds to 180. So isosceles triangle, a very friendly triangle to work with. All right, let's just finish out these notes here. All right, so the next blank, A,
Transformation
is an operation that maps an original geometric figure, the
pre-image
onto a new figure called the
image.
yes. Transformations can change the position, size, or shape of a figure. But in a rigid transformation, also known as a congruence transformation or isometry, only the position changes, the size and the shape remain constant. So a transformation is just an operation where we start at the pre-image and then we go to the image. And you've learned about these in middle school. This is basically just a review. And like I said, you can change the position, the size, or the shape, but we are simply going to change the size and shape. Sorry, we are simply going to change the position, excuse me. And the size and the shape are going to remain constant when we look at these rigid transformations. And you can see these in your notes and kind of read about them. Again, you're familiar with the reflection, also known as a flip. Okay, so like I said, a reflection or a flip, you can use either term, reflection is the more formal term, is a transformation over a line called the line of reflection. I'll just kind of put my pen there for a second. Each point of the pre-image and its image are the same distance from the line of reflection. So you can see how basically this triangle just jumped right over and then landed on the other side. And notice that triangle ABC has now become triangle FGH. Notice the A is an equal distance from the line of symmetry or the line of reflection as F, equal distance apart. Notice that B is equidistant to this line as G is, and C as H. All right, the next one is a translation, also known as a slide. I like the nicknames because it really shows you what's happening here. It's a transformation that moves all the points of the original figure the same distance in the same direction. So this triangle just slid right over to there. And finally, we have a rotation. Another word for rotation would be a turn. A rotation is a transformation around a fixed point called the center of rotation through a specific angle and in a specific direction. Each point of the original figure and its image are the same distance from the center of rotation. So you can kind of take a look here and see how point R would now match up to where point W is, point S would match up to where point X is, and point T to where point Y is, just like they turned the triangle. All right, let's go ahead and take a look at our classwork. All right, you will find your classwork / homework assignment right on this page. It's 4.6 is on page 289, and your 4.7 assignment is on page 299, and the problems are listed both on your notes page and on your Google Classroom. Oh, and it looks like there's the bell.
Bye, Mrs. Travers.
Bye, guys. Have a great day, class.